So hopefully this records okay. Okay, so what you're asked to do is similar to what we're doing so far. The only difference is that it's already been partially set up. Okay, we're not asked for an end view in this case, but we are asked to figure out, well, where does this bit come up to meet this, which is the easiest bit. So what sort of shape will that make going into this? And then the same on this side. So basically to say it's something like this fancy house. It's not exactly the same. Something like a house that has sort of these fancy outjuts going into it. This is sort of a windowed structure or something going through your face of the building or whatever the case is. So it says the image below shows a building and the drawing shows an incomplete elevation and plan of a similar structure where two prisms penetrate each other. In the drawing, the triangular prism intersects the irregular pentagonal prism, which has been cut. So basically all they're saying there really is, I don't know if I don't have a grey mark with me, but if you imagine this is the roof, basically you have a triangular sort of windowed structure, something like this, going into your typical sort of house structure, but it's a bit unusual at the back. So I'm going to start off with this side here because it's the easiest side to figure out. Okay, so what we would do typically is once we have this drawn, we bring up these points here, and I'm going to call them A1, C1, and B1. I probably should have brought thinner pens because I'm zoomed in. They may have worked, but this is all I think I have here handy. So I'm going to bring these up. Okay, so A1 will go up as far as where A is, B will go up as far as where B is, and C will go up as far as where C is. And that's sort of my basic structure or my basic intersection points. So again, I could label them. This is C1, this is B1, and this is A1. Okay, and what I can do is I can join them together. Now I'm going to mark them in with hidden detail for the minute, because that way I can go over them with the solid line. Okay, if I mark them in as all hidden detail, even though technically they aren't, I can then decide to go over them afterwards. I can't sort of rub out the pens that I use. Okay, so that's basically when that intersects into the house. So if you could walk, if this was, I don't know, a living room or something unusual like this, and you could walk in, you'd walk in through this sort of structure here to get into the house. Okay, so we'll extend that one on, and you'll see that when we extend that one on, it overrides the hidden detail line that was there. So a solid line will always go across a hidden detail line, and if the hidden detail line is behind it, you can't see it. So then you have to figure out, well, which one will you see? You'll see between B and C, if you imagine like this, but then the other one is coming on the back between A and C. So this would be solid. Okay. So that's basically my structure going in there. So I'm just trying to see if I have a color pencil handy. I have a yellow here. Okay, so that's basically that going into that. Okay, it comes out green on the visualizer for some reason, but it was a yellowish color. So I have to do something similar here, all right? But I have a different issue here in that there's instead of this being one solid slope, there's sort of a kink in the slope. So we look at what happens in that case. So the first thing is, if you don't understand the question, or if what I've done so far doesn't fully make sense, again, you need to be able to attempt it. So you need to know that you need to bring down every single point where they crisscross. That's the first thing. And I'm going to ignore this point for a minute, and I'm just going to do the same as I did for A, lines up with this. If you look at that, you'll see that A lines up there, C lines up here, and B lines up here. So I'm just going to call this A2, maybe I'll use a green instead this time. So I'll call this A2, no, sorry, C2. This would be B2, and then there will be A2 behind it. So this would be B2, or sorry, where these two crisscross will give me around where B2 is. We'll find them now in a second, and then C2 is going to be somewhere over here. Okay, so what I'm going to do is I'm going to extend on that to meet it. Extend on that to meet it. Sorry, my A doesn't look exactly right there, but just because of the thickness of the markers. So there's C2, there's A2, and there's B2. Okay. Now there's another point along here. Actually, that line should, if it was accurate, when my page stuck out, be exactly along that. So we need to figure out where exactly this is. Now, this bit is difficult to understand. And if you don't get it today, I wouldn't worry about it because it's, you know, it is one of the more difficult things to understand. It's called using a cutting plane in order to solve it. So what you'd have to do is you'd have to imagine, well, if I cut off this part of the building, so in other words, all this bit above it, all this bit up here disappears, what would this orange line look like? So if that was, or if it was, I don't know, like a kid's toy that you could pull off that part of it, what would the orange line look like? So we know that the orange line hits here, okay? So it would hit there and there, so we know how far up this pitch that it would be. And I could bring that across, and I could bring that across, and we know that these points here, I'm just going to call them point, let's see, we'll call them S and T, just to use something that's not near the letters that I use it. S and T, so S and T are there, and they're partially up that. Okay, so that means that this is basically the view that will get. So there'll be a slight difference in the angle. My one, for some reason, on this side doesn't look too much of a difference on the top edge. Okay, it's a little bit difficult to see. And these will just extend out to meet this. And this will just extend out to meet this. Okay. So if anyone has any questions there, they can ask me. If they want to wait till I'm finished recording the video, they can do so. So that would be basically what it would have looked like if I cut off that orange section. Sorry, it would have looked like that as far as here. And then this is obviously the C part. So I'm not too worried if you don't fully get it, but I just want you to get to it because I'll have better models to show when we get back to class. But it just gives you some idea as to how you would attempt a short version of this question. This would be a higher level short version, and what we've done so far would be ordinary level standard. So that's why there's a bit of a step up there in what they're asking you to do. But this side here should be fairly doable, and you should be able to get them outside points. S and T might cause a little bit of difficulty. So if I have no questions there, I'm just going to do part B as well. And as I said, I can pause the video afterwards, and if anyone wants to ask questions, they can do so. So the next bit says, determine the true shape of the triangle ABC. So the problem with ABC, if we imagine it's a window, is the easiest way to think about it, right? So it's like one of these windows here. What they mean is they want to go the true shape. So say if we have to send off the dimensions to a glazer or a person to make this window, right? What you'd get would be the carpenter or whoever was measuring would come out, he'd measure these sizes here. When we look at it from the plans, if we're an architect and this hasn't been built yet, right? What the problem is, we can't see the distance here in this view from A to B because it's sloped away from us. Okay, it looks sort of straight on there, but in our case, it's sloped away from us. What we can do is we can see exactly looking straight down what the length of the line from A to B is actually in reality. So what you're looking for is what I do is I'd highlight the surface. The second thing I do is see, do you have a view where you can see that surface that they're looking for as an edge view or as a line? Okay, so we can see a line of it here, right? So there are two ways you can do about this. So I don't know what way you might have done at Junior Cert. So I'm going to show two different methods here. Okay, the first method I could do is I could draw it and say, right, I'm just going to draw it out to one side. Okay, so I know that the true length of the line AB is actually this size. So that's the actual length of AB. You can see there it's substantially smaller in that view, but that's because it's tilted away from it. Okay, so that's the true length of A to B. Okay, so we write A on this side and B. And in this view, I know the true height. So if I bisect this line, just to get the center, now I suppose I could technically just measure and divide it by 2, but I'd be expected to bisect it just for accuracy. And I draw a line up the middle. And I take my height here. That's the real height. Okay, so that's point C. So now I have the window drawn out to one side, and I could send it off to the manufacturers and say, well, these are the sizes of it. Okay, this is the height or this is the width at the widest point at the bottom. Okay, so I took the height from this view and I took the width from this view. So again, hopefully that makes sense. There is another way of doing it, which some people may understand easier. This is from question 1 on the junior cert when you were doing plan elevation end view and you're asked to do the true shape of an object. So what you want to do is, another way you can think about it is say, well, right, instead of thinking about it that way, what if I imagine the window was on a hinge, right? So if I imagine the window was on a hinge and that one of these windows here could be literally, I don't know if you ever watch Dermot Bannon Room to Improve or you watch Grand Designs or anything like that, you'll see there's a lot of these fancy windows that can be either slid apart or they can be rotated. So we can imagine that, say, well, what if this window here could be opened out? So in the summer, it's on a hinge on this side, right? Ours is a triangular one rather than this sort of shape one, but there's on a hinge point here and literally it can be all twisted out so that you know, it lets in all the fresh air the odd few days we have good weather. So that would be the way it would spin around until it came out level with A. And if I bring that up here and I draw, well, what would that look like? A would be where the hinge would be, okay? B would have swung around to here, okay? So this would be the open size. So that would be the A to B. I can also say, well, right, I'll rotate around C as well. I just need to adjust up my pen. Okay. And then if I bring C up here, when it opens, you would imagine the height of it, if you can think about it, the height will stay the same. So C, when it opens, will now move over to here. And now basically I can join that. Sorry, my set square fell down. That'll be the new position for C when it's opened. And that's an alternative way of doing it. Okay, so both methods are acceptable. Typically people would use the rotated method. It would be more likely because it's sort of easier for people to visualize and it's easier for it to get done quickly. So it's less likely to make a mistake. But if you didn't understand it, you could do this. If you didn't understand it at all, the worst you could do was redraw another triangle somewhere on the page, or even just redraw exactly ABC. Because if you redrew this exactly, you'd have the height right. You wouldn't have the width right, but at least you'd get some marks for it. Okay, so I'm just going to stop the recording with this.